as promised on the syllabus, chapter number 16 was going to be fully online. It was going to be asynchronous, and that's what we're doing right now. So welcome to my dojo. I don't even know what a dojo is. Here is my studio, makeshift studio, and we are going to be going over chapter number 16, and this is going to be called Technology in Biomechanics. And some of the technology we're going to be talking about, just some of the basics of it, and some of this is even just some of the basics of research in exercise science, really. Going into some measurement issues that could come into play in the laboratory versus in the real setting, maybe out on a court or a gymnasium. A mat could be a football field, soccer pitch, could be track, anywhere. Maybe some of the issues, maybe environmental issues that could come into play there, and also other people possibly getting in the way, which I've seen before. It's strange at times, professional sports and even collegiate sports, and even going way down into like Little League and Pee Wee football and stuff like that, people getting in the way, not just players and maybe parents or spectators running out on the field, but officials can get in the way, which can throw some things off. In the laboratory, it's more of a controlled setting. That's really what the laboratory is for. And so that's going to be where a lot of our core data is going to be. And then from there, we take it out into the field if we can. Some pieces of equipment, you just can't be as mobile as you would like to be. So anyway, then get into some of the actual types of equipment, maybe radars, accelerometers, get into radar guns and lasers, potentially. Accelerometers being a big one, stopwatches, and any type of automatic timers. Again, just some of the basics. We're just going to go over them fairly quickly. Not going to go too far into depth of each specific piece of equipment, but just say the basic, category that they are in. And then from there, what could they be used for? And any type of maybe high-speed photography. Accelerometers are a big one. Force platforms are also big. Force platforms and also insoles, pressure insoles inside of the shoes. And that's where we're going to kind of wrap this chapter up. So it's a fairly short chapter. I didn't think that it was warranted as a full come into class and we'll do this lecture. It would have been a pretty short class anyway. And I think we were kind of ready maybe for something asynchronous. I think some of you may have already wanted asynchronous anyway, which was, we were doing synchronous, but you maybe wanted some more online stuff. And, in this, the time we're going through during this semester, maybe some of this is best. So who knows, but this is going to be chapter number 16. I'll see you on the flip side then. Chapter number 16, Technology in Biomechanics. So this is a picture here of what is known as a Tendo unit. And you can see in the barbell, they have their namesake on the barbell, or at least the plates there. And what this piece of machinery does, it's a piece of electronical equipment. And it actually has a cord or a cable that is running to the barbell itself. It hooks on to the clips of the barbell. And from this, you're able to determine the velocity of that bar and know how far it actually moved. So therefore, you can determine power output. So obviously really important in training applications, but also in biomechanics. You can also incorporate this with video and determine how straight that bar is going up and down. And you can use this with multiple different exercises. It doesn't have to be a bench press. It can be a squat or a deadlift. So a very neat piece of equipment that has been developed within biomechanics. So one thing we do need to cover here is some issues that we could have in measurements that we're taking, either in exercise physiology or in biomechanics. It doesn't matter what the field is. So first off, we have the quantitative measurements. So that's the timing, how long it takes to get from one place to another, from point A to point B. The kinematic, the changes in the position, the displacement, the velocity over that period of time. And also the kinetic forces, the energy, the power output that somebody has. And some instruments may actually affect performance. So let's go back real quick to this picture of the Tendo unit. Most likely, this is not going to affect the power output of the individual. It's not really going to affect the biomechanics of actually lifting that weight. However, somebody could know that, well, I'm actually being studied So I may perform a little bit differently in this case. I may go full range of motion when I normally don't. I've seen that before. But something like this, it's actually really smooth and it doesn't really impede any of the motion very much. But there are pieces of equipment that could potentially impede the motion. A lot of times we'll see that in exercise physiology, but it is something to be aware of. Also keep in mind that lab data is in a controlled setting. Most of the time it's in a controlled setting. It's as controlled as possible. In fact, that's the reason you perform laboratory studies, is so you can control a lot of the extraneous variables that could be coming into play with any particular study, range of motion, exercise. The lab itself could actually influence the participant because of the environment. It could be a different temperature than they're used to working out in. It could be a different humidity. The lights could be vastly different than what they're used to working out in. Even something as simple as how high the ceilings are or how far away they are from the wall when they're exercising. That can play with somebody's mind a little bit in terms of their depth perception and how small or big the room feels. Some people that may be claustrophobic, if the ceiling is really low, they may get a little bit nervous about that. Even though it's still a normal sized room, maybe they're up on a treadmill and they're a little bit taller now, it could still affect them. So the environment does play a role inside of the laboratory. Now, the best case scenario is to be able to take the data actually out in the field where the specimens, the physical specimens that we're trying to study and to analyze are actually in their natural habitat. And those are the athletes actually out on the court, out on the field, out on the track, the mat, wherever it may be. Oftentimes that is going to be somewhat difficult to do because if they're wearing a device that is maybe in the multiple pounds, maybe it's not an accelerometer or a heart rate monitor, but it's something that they got to wear on their back, almost like a backpack. It's going to be really difficult to get somebody to volunteer to actually wear something like that when they're trying to compete. Also, the equipment may not actually be portable. Some of the stuff, the Tendo units are fairly portable, but force plates and to a certain extent, high-speed photography cameras aren't as portable as we would like them to be, at least not at the moment. Maybe in the future sometime they're going to be pretty portable. But there's a lot of lighting that goes into a lot of high-speed photography, so that may not be as portable as maybe someone might think. And the tests do need to be non-invasive. If they're invasive, if they're causing a little bit of pain and discomfort to the subjects, such as maybe blood draws or muscle soreness or just pain because of the device that they're wearing, could be maybe uncomfortable, that's going to throw off the data quite a bit. And the biggest factor here is the environmental control is greatly reduced. The weather, the lighting, the other athletes, the spectators, and the officials, they're all going to be there. That's going to affect them quite a bit physiologically and also in turn biomechanically then. And another thing to note is some of the other athletes, spectators sometimes, and also some of the officials could potentially get in the way. I'm sure you could look up on YouTube a lot of videos of spectators running out onto the field and interrupting a game or a race. It's happened with officials at times and other athletes. Let's look at some tools for measuring biomechanical variables. On the kinematic measurement side of things, we got radar guns, accelerometers, and also cameras, high-speed photography. Now, a lot of this stuff is becoming much more advanced to the point where some of it is actually in our phones now. Maybe not radar, but some accelerometer data is in phones, is in smartwatches. The cameras in the phones has become fantastical, if that's a word. I don't know if it's a word, but I'm going to be using it right now. The phone cameras are getting so good that some of the maybe DSLR cameras and the really expensive cameras are really trying to keep up with the phone cameras. However, that type of stuff is generally going to have better control just because it's going to be bigger. You can put a bigger chip into it, a bigger computer chip. But the phones and the camera are getting so good that we can take a lot of these measurements within the phones themselves. So maybe at some point we will have radar and be able to track the velocity of a baseball or a human running down a track just by pointing our phones at them. I'm sure that's probably the next thing. Now, some timing devices, we're looking at watches, stopwatches, some automatic timers, maybe that have lasers that are going to go off or start when somebody starts and goes right past that little beam of light and then ends when they go past the second beam of light. Now for this, they're taking the average velocity. They're not taking the instantaneous velocity of that individual. They're taking the average velocity and determining about how fast they're moving down that track or in that motion, whatever direction they're going over that distance. And radar guns, like I mentioned in the radar portion here in the kinematic section, they're really good for implements and projectiles that we are throwing. Baseballs and softballs are really the big thing here with the radar guns. They're used quite a bit. However, they are limited in measuring any type of body movements unless it's the entire body itself, but just maybe the arm velocity. Probably not going to be able to take that with a radar gun. You're going to need more high-speed photography and also reference points behind the arm itself. We also have lasers. So these actually have a tighter beam than radar, so they're better for pinpointing subjects or objects. Quick story here. One of my good friends is a state trooper in Pennsylvania, and he has told some of his colleagues that, it would be better if we actually use lasers instead of radar guns. Some states actually use lasers. You can actually track a car and pinpoint a car at a further distance with these lasers than using the radar. And it does tend to be a little bit more accurate in that case too. But the lasers are definitely good in biomechanics for objects and also human motion. So tracking how fast the body is moving. And then we have optical imaging. So we're looking at the frame rate and the change in position between the frames. So this is the high-speed photography that we're talking about. And it could also be some 3D modeling involved there where we're putting sensors on the body at different points and tracking that motion through a computer program. This is the same type of technology that is used in a lot of video games now. And with the use of multiple cameras, now you can get a 3-dimensional model of that particular individual, of that joint, and look at the movement through 3-dimensional space. Accelerometers has really exploded in the past decade or so. A lot of research has gone into these devices, and there's a couple of different versions of them. There's the uniaxial, which is just simply measuring acceleration in one particular direction. So usually forward and backward, potentially side to side. And then there's the triaxial. So you're looking at more of a 3-dimensional space in those 3 axes that are perpendicular to one another. So up, down, left, right, forward, and backward. These are also good because they give really high sampling rates, which means you can analyze this stuff down to the fraction of a second, how quickly someone is moving in any of those directions. And you can also put these devices inside of airbags, helmets, possibly even some playground equipment to see how they're actually moving through space, through time and space, actually, if you think about it, through time and space, and determine potentially how the forces are being applied to those particular devices or the human body. So we have a picture here of one particular accelerometer. This is going to be more of a high-end one, maybe a little bit different than what you might be getting at Walmart or wherever you might buy some of this stuff, but it's still doing the same stuff. It's still tracking the movement in those 3 axes. And then on the right, this is what it would graph out to be. Sometimes these will actually give even different units. And by the different units, I mean they will be literally units. They'll just say this person during this period of time moved this amount of units. And these units could be calories. They could be a certain velocity, could be angular velocity, whatever it may be. The manufacturer is going to determine that. But some of the graphs you'll get from this stuff is going to look pretty similar to this. So there's an uptick in movement in one direction and then another direction, and then leveling off towards the end here. So something similar to this. Now the kinetic measurement tools, these are going to be looking at the causes of the change of motion. So the forces being applied to either the ground or the human being. One of the most common pieces of equipment here is a force platform, or what's known as a force plate. So here's a picture of it down here. This individual is stepping on this force plate. The one thing about a force plate is that it needs to be embedded into the ground, into the floor of that particular building. So it needs to be concreted into the floor itself. And this is to ensure accuracy and it doesn't move. It needs to be perfectly level. But once everything is working properly, it can measure the reaction forces and the point of application, the actual specific portion that the force was applied, and also the direction of the resultant reaction force that was being applied, in this case, with the foot. You can determine normal force or vertical force. Frictional forces could also be measured during this stage. Frictional forces can also be measured during this type of activity and testing. And one common measurement that researchers will try to get here is the ground reactant forces and also the gait of the individual. Where are they applying the pressure on the soles of the feet? How much force are they pressing off of? How much force are they putting on the foot as they're stepping down with just one foot, or maybe landing from a jump of a certain height? So really important in biomechanical research in determining somebody's gait, how they land, maybe injury prevention in that case. Now, these force platforms are specific equipment that you need to embed into a floor. However, you can actually take this concept and make it a little bit more mobile. So you can have pressure sensors within mats that are going to basically measure the same things, the forces, the reactant forces, possibly the frictional forces. And these tend to better show maybe the distribution of the forces, maybe over certain areas which the forces are being applied, and also analyzing gait by just simply walking across the mat. And these mats could be maybe a little bit bigger than what the force platforms are, what was shown in this previous picture right here. You can maybe even take this a step further and put them into the soles of the shoes themselves. And this is where some of the technology is leading. Some of these pressure insoles can have a small microchip in them and can have a Bluetooth sensor, and then that can go to a phone or even a computer and be analyzed real time. So you can look at the pressure that somebody is applying in a certain area of their foot as they're stepping, landing, and then pushing off, but also as they're maybe landing from a jump, as they're cutting, changing directions really quickly in certain movements, in certain drills, all trying to discover what is the most biomechanically efficient motion for that particular individual and what could be deleterious forces, meaning that which ones could potentially be causing some movements that could lead to injuries, or at least the increased risk for injuries such as ACL injuries or maybe ankle sprains. Okay, that was chapter number 16. I will see you in 1 second back in my dojo. Welcome back to my dojo. Again, I have no idea what I'm talking about. It's late or early, however you want to think about it on the time here. But chapter number 16, going over some of the measurements and some of the equipment that is used in biomechanics. And some of this isn't specific to biomechanics. It can be used in a lot of different areas, but it is really biomechanically related. The speed, the velocity of objects, the human body, the joints, the angular velocity of the joints, the power outputs during weight training. Being able to use something like a Tendo unit is really a vital piece of equipment. I wouldn't say necessarily vital, but it's a very important piece of equipment if somebody can afford it, if they're a trainer or they're a strength and conditioning coach or just a coach. College could use these to determine the power output of somebody during a certain exercise, the bench press, squat, deadlift. As long as there's a bar there, something to hook up that piece of equipment to, and the weight is going to be moved a certain distance, that piece of equipment is going to be able to determine the velocity and the distance that it actually traveled, because that piece of wire or that cord is attached to it and it's going to move a certain distance, and it's pretty precise. It goes down to, centimeters, even half centimeters. I think maybe even 1/10 of a centimeter, how far that cable is going in and out of the wheel inside of the machine. So very precise piece of equipment there. So very important for training purposes, and could even be used for rehabilitation, seeing how quick somebody is maybe getting the weight moving and, through their workout regimen that maybe they're trying to rehab a leg or a shoulder, an arm, whatever it may be. So thank you for watching, and I thank you for a good semester One thing I want to say is that I muffed up on the quizzes. I got behind a little bit at the beginning, and then I graded them, and I didn't realize I had to kind of do a posting of the grades, and that's why you have not been able to see them. So that's my fault. That's on me. I'm going to be making that up somehow, some way, because you weren't able to see basically the grades that you were getting on these quizzes as you were kind of going along. Now, some of them, only half of you had finished at a certain time, and I wanted to try to get them all done kind of at once. But some of those other ones I had graded for a couple weeks, and you guys weren't able to see them. That's on me for not knowing that. So I'm not going to blame whoever at Blackboard or somebody else. I'm not going to do that. It's on me. I should have known that. So anyway, that's my confession. It's my dojo confession. Thank you for a good semester. I hope you learned something about biomechanics. I do wish, and at some point we have equipment for this class so we can go over some of this stuff. Unfortunately, some of this stuff does cost money. I didn't go into the cost of a lot of this stuff, but some of it is fairly expensive. A lot of stuff is expensive, relatively speaking. But some of these pieces of equipment you could test out and use if you know somebody who has them, if you know a gym who maybe has a Tendo unit or something like that. So I am looking to get some of that, but maybe I'll go into a different video. I need to start making some, update videos and stuff like that here soon to kind of go into some of that about laboratory stuff. So I rambled, didn't I? Squirrel! Thanks for watching. Thank you for a great semester. I hope at some point I get to see all of your faces, your actual whole faces at some point. So, but until then, I hope to see you in my office for advising or whatever problems you may have or any advice you may need, or even just shooting the shit, whatever it may be, whatever you want to do. Take care. Man, nothing like water to quench my thirst at 3 a.m. when I'm trying to finish this stuff up. Man, I wish I could get better sleep, but I don't.